Hello everyone, welcome to this video. In this video, we are going to see how to solve the type 2 homogeneous linear PDE. So type 2 homogeneous linear PDE, in that we consider our right hand side function f of x comma y as a trigonometric function. That may be a sine function or that may be a cosine function of the form sine of ax plus by or cos of ax plus by. So for this case, how we are finding the particular integral? So here we give the replacement for d square as minus a square, and d dash term is replaced by minus ab, and d dash square term is replaced by minus b square. So here for all the three terms we give the substitution, and when you replace these by these, and if you are getting the denominator is non-zero, means your particular integral is obtained. Suppose when you replace these d square, d dash and d dash square by these, your denominator term f of minus a square minus ab minus b square is equal to 0, then we have to proceed like type 1. So now let us see some examples so that you will be able to easily understand how to solve the type 2 homogeneous linear PDE. So this is our first example. Solve d cube minus 2d square into d dash into z is equal to sine of x plus 2y. Here first we have to find out the complementary function by considering the left hand side. So for finding the complementary function, first we have to write the auxiliary equation of the given. So the auxiliary equation is replacing d by m and d dash by 1. We are writing, that is, the auxiliary equation will be written in this form: f of m comma 1 is equal to 0. Actually we have f of d comma d dash into z is equal to f of x comma y. So this is what our given form. In this, by replacing d as m and d dash as 1 and equating that to 0, we get our auxiliary equation. So here the auxiliary equation is m cube minus 2m square is equal to 0. From this I can take m squared outside. So from this it is m minus 2 is equal to 0. So from this we get m is equal to m square is 0, implies that m is equal to 0 comma 0, and m minus 2 is equal to 0 implies that we get m is equal to 2. So all our three roots are 0, 0 and 2. So the roots are m is equal to 0 comma 0 comma 2. There the first two roots are repeated, the last one is distinct. So how can we write our CF here? CF is phi 1 of y plus 0x, that is, we can omit that part. So it is phi 1 of y plus x into phi 2 of y plus 0x, which is nothing but phi 2 of y plus phi 3 of y plus 2x. So this is our complementary function. So now we are going to find out the particular integral. So for finding the particular integral, we have to consider our right hand side function, that is sine of x plus 2y in the numerator and the function of d and d dash in the denominator. So to find pi, we take our right hand side function sine of x plus 2y, sine of x plus 2y in the numerator and the function of d in the denominator, which is d cube minus 2d square into d dash. So here we give the substitution for d square term. D square term is replaced by minus a square. So this is not minus a the whole square. This is after finding a square, you have to put negative sign. So here this is our a. Our a is 1. We have sine of ax plus by form, and our b is 2. So here d square is replaced by minus a square. So it is a square is 1. So it is minus 1. And d dash is replaced by minus a into b. So first we have to find out ab and then we have to put negative sign. So A is 1 and B is 2, so it is 1 into 2, so 2, and it is minus 2 then. Next is D dash square is replaced by minus B square. So our B is 2, so B square is 4, and then put negative sign. So B square is here 4, therefore D dash square is minus 4. So now we are going to replace these D term like this. So in the first sine of x plus 2y. So in the first term, I can write this d cube as d into d square. Then I can give the substitution for d square as minus 1. So the first term becomes minus d then minus. So here I have two options. Either I can give the substitution for d square or else I can give the substitution for d dash. So if I'm giving the substitution for d dash, then I'll be having minus 2d into d dash is replaced by minus 2. So from this what I'm getting, sine of x plus 2y by minus d here plus 4d, which means sine of x plus 2y by 3d, that is 1 by 3 into sine of, that is 1 by d of this, 1 by d of sine of x plus 2y. We know that d is dou by dou x, so 1 by d is integration. This is partial differentiation. If d is in the numerator, we have to differentiate the function partially with respect to x. But here d is in the denominator, so 1 by d is integration. So we are going to integrate this function with respect to x partially. So what we get from this, 1 by 3 into, so integration of sine is minus cos, so it is minus cos of x plus 2y, it is with respect to x, so that the here x term becomes 1. So this is what our particular integral. So finally we can write our complete solution as, that is z is cf plus pi. That's it. So this is our second example. Here we are going to solve uh, the given equation. Here in the right hand side we have a product of two terms, that is sin x and cos y. So first let us see how to solve this. Since we have both left hand side and right hand side, by considering the left hand side we are going to find out the complementary function. That is, to find the complementary function, first we have to write the auxiliary equation. So here the auxiliary equation is m squared minus 3m plus 2 is equal to 0. Solving this we can find out the two roots. So here the product must be 2 and the sum must be minus 3. So it is minus 1 minus 2, and so the roots are 1 and 2. So here the roots are 1 and 2 and that are distinct. So we have got distinct roots. So CF takes the form phi 1 of y plus 1x, that is x, plus phi 2 into y plus 2x. So this is what our CF. Next we have to find out the particular integral. For finding the particular integral, we have to consider our right hand side function in the numerator and the function of d in the denominator. It is to find pi. Our right hand side function is sin x cos y, and the denominator is function of d and d dash is d square minus 3d d dash plus 2d dash square. So here first you have to see the numerator. If there is only one sine or cosine term, then directly you can go for applying the procedure. That is, you can give the substitution for d square, d dash, and for d dash square. But we have product of two trigonometric functions in the numerator. So first, using the formula, we have to express it in some form. As we all know, the formula for sin A cos B, using the formula we can write the same as sin of A plus B plus sine of A minus B by 2 gives sin x cos y. So sin A cos B can be written as sin of A plus B plus sin of A minus B by 2. I am taking that by 2 as 1 by 2 in product, and in the denominator we have the function of d square minus 3d d dash plus 2d dash square. So now we can separate the terms. We have two terms, so we'll separate the term. So first term is 1 by 2 sine of x plus y by d square minus 3d d dash plus 2d dash square. So let us take this is our particular integral one, and we'll find the particular integral separately for the first term now. So here we have to give the substitution for d square is, here our a is 1 and b is 1. So since a and b both are 1, so d square is minus 1 and d dash is minus 1 and d dash square is also minus 1. So when you give these replacement for all the d terms, we get 1 by 2 into sine of x plus y by the denominator we get minus 1 minus 3 into d dash is minus 1, so that becomes plus 3, and here it is minus 2. So here we get the denominator term as 0. So we have to proceed like the type 1. So whenever the denominator vanishes, what we have to do? We have to take x in the numerator. First time we are taking x. For next time we have to take x square by 2 factorial. First time the denominator vanishes, so we take x in the numerator. So we have x by 2, and then we take our function sine of x plus y, and we have to differentiate the denominator with respect to d alone. So it is 2d minus 3d dash. So now we have to apply the procedure again, but there is no square term. So for type 2, if there is d square, d dash and d dash square only, we can give the substitution. So I want the square term here in the denominator, so I'm taking the conjugate of the denominator, and I'm going to multiply both numerator and denominator by its conjugate. So this comes as x by 2, 2d plus 3d dash of sine of x plus y by, in the denominator it is 4d square minus 9d dash square. So now when you replace this d square and d dash square, this d square is minus 1 and d dash square is minus 1, so that comes as minus 4 plus 9 is plus 5. So you are getting x by 10, since we get 5 from this d term. So 5 into 2, we are getting 10. So in the numerator it is 2d of sine of x plus y. 2d, that is 2 into d of sine of x plus y is, d means dou by dou x. So it is cos of x plus y, and plus 3 into d dash of sine of x plus y, means d dash means dou by dou y. So which is also cos of x plus y. So from this we get 5 cos of x plus y, that is we get x by 10, here it is 5 cos of x plus y, and we can cancel this 5 here, so it is x by 2 cos of x plus y. So our particular integral 1 is, x by 2 cos of x plus y. So now we can find the particular integral 2. Okay, so for we consider the second term. So the particular integral 2 is 1 by 2 sine of x minus y by d square minus 3d d dash plus 2d dash square. Here our a is 1 and our b is minus 1. So here d square is replaced by, since a is 1 and b is minus 1 for the second term, here we have sine of x minus y. So our a is 1 and b is minus 1. So d square is replaced by minus 1, d dash is replaced by plus 1, and d dash square is replaced by minus 1. So when you give the substitution here, we get 1 by 2 sine of x minus y, and in the denominator it is d square is minus 1, so it is minus 1, and d dash is plus 1, so it is minus 3, and d dash square is minus 1, so it is minus 2. So the denominator is minus 6. So it is minus 12. So this is our particular integral 2. So now finally we can write our complete solution as CF plus PI1 plus PI2. PI1 is x by 2 cos of x plus y, and PI2 is minus 1 by 12 sine of x minus y. Thank you.